Hello, my name is Dan Davies and I'm going to show you some of the features of the Tamron DF023Q0 motorized lens. So this is the Tamron DF023Q0 motorized lens. It is 4K 2K compatible, so very high resolution. And to point out some of the features, up on the top there are two stepper motors here and on this side here, connected to lead screws. And these are used to drive the zoom and focus elements of the lens. There is also a galvanometer here at the top, and that's used to drive the removable IR cut filter in and out of the optical system. So this is an IR corrected day-night lens. Very high resolution in the IR wavelengths as well. And it's not visible from here, but underneath there is a third stepper motor, and that's used to drive the iris. So this is a stepper motor iris lens. Also inside the lens there are two home position sensors for the zoom and focus stepper motors. And those are used to detect the home positions of the zoom and focus. So this could be used if you want to drive to preset zoom and focus positions, or if you want to maintain focus when you're moving through the zoom stroke. So I've got the lens attached to an Aptina headboard here. This headboard is using the Aptina AR0331 3 megapixel sensor. And in between the lens and the headboard there's a piece of plastic. This is a 3D printed piece of plastic that looks like this. This is just something I designed on the computer and used a 3D printing service to print. And it goes in between the lens and the headboard to maintain the proper flange back distance between the lens and the sensor. So all of the lens components are connected through this orange FPC, flexible printed circuit. And I've got that connected to a clip connector that breaks out all of the pins and connects them to this prototype board that I have here. So here are all the wires from the FPC. And there are three stepper motor drivers, one for each of zoom, focus, and the iris. And I have 6 push buttons here that are used to drive these stepper motors in each direction. And connected to the proto board I have this Arduino UNO microprocessor. And this microprocessor is programmed to take inputs from those 6 push buttons and send the appropriate speed and direction information to the 3 stepper motor drivers. And the drivers in turn send pulse signals to the drive coils in the stepper motors in the lens. I also have 2 push buttons over here. These are to move the IR cut filter in and out. So these send a voltage to the galvanometer to activate that. So today I am imaging these 2 stuffed animals here. So I've got the lens and the camera pointed at them and connected to my laptop here that's doing the live imaging. And I have that also connected to my TV. And so I'm going to point my camera at that TV and show you some of the features of the lens. So this is a focal length 2.8 to 9.8 millimeter lens. Right now we are in the wide view looking at the stuffed animals at focal length 2.8 millimeters. So we can move the focus motor in and out to change the focus. So right about here it looks like we have the best focus in wide. And we can also control the iris. So right now we're somewhere between open and closed, but if I start closing the iris we can see that the image gradually gets darker as the aperture closes. And we do have control over this since it's a stepper motor, so we can close it all the way down so that the image gets pitch black. So this is one of the advantages over the standard DC iris. With the stepper motor we can control the iris to any position that we want, so it gives us control over depth of field and things like that. So I'm going to zoom into the tele side of the lens now, to the 9.8mm side, to get nice and close to these two stuffed animals, and I'll have to refocus. Alright, I'm up there. And since we did go to the tele side, the image got a little dark, so I'm going to open the iris up a little bit to brighten it up. And there we go. That is the image at 9.8mm. So I mentioned this is an IR corrected day-night lens. So it's a really good lens for night vision. And I'm going to show you how the lens can be used for that. So right now I have an IR illuminator sourced, pointed at my two stuffed animals here. It's an LED source at 850 nanometers wavelength. So this is a wavelength that is not visible to the human eye. So it's good to show how this lens can be used for night vision. So in order to show you, I'm going to turn off all the lights, and I'm also going to have to turn off the TV because that's emitting some visible light, and I want to make the room as dark as possible. So I'm going to move the camera over to the laptop and image directly from the laptop. Yeah. So that's about a full screen view of the laptop. And now I'm going to turn off the lights. So you see that the image went pitch black. The video is picking up a little bit of light from the PC. But the stuffed animals are no longer visible. So the 850 nanometer IR light is still illuminating the subjects, but the IR cut filter in the lens is in the way of the optical path, so that IR illumination is not passing through the lens. So when I move the IR cut filter out of the lens, which I'm going to do now, the IR wavelengths will pass through the lens and be imaged by the camera. So I'm going to move it out now. And you can see that the duck and the dog are now visible. And they're also in pretty good focus. I didn't touch the focus motors when switching from visible to IR. So this means that the focal planes for visible light and for infrared illumination are very close, which means there's no need to refocus when we move from daytime mode to nighttime mode. And I'm going to lift the video camera up a little bit to show you that the room is pitch dark and the stuffed animals aren't visible to the human eye, but in night vision they are visible. So I'll turn the light back on again. So that was a demonstration of the features of this Tamron DF023Q0 motorized lens. And if you have any questions, please feel free to leave a comment on the video. And if you're interested in using the lens yourself, I'd be happy to share some design schematics for this prototype board or any of the code for the microprocessor that drives it. Thanks very much for watching.